Hey, John.
Hey guys, I got my drink. I'm ready to go.
Nice.
I didn't know it was that kind of party.
Yeah. Well,
It's a
Arjun
coffee,
stepped out
but
of the party. It's,
Hey, I got my drink with me. It's fine.
nice. Nice. Okay, Yorkie's here as well. Everybody's here. Okay, welcome everybody to our first edition of Arbitrary Messaging, joined with Hyperlane team and our hosts Arjun and Mark, who wrote the Arbitrary Messaging Bridges Comparison Framework. It's going to be a nice, interesting conversation. I'm first looking forward to it, and I'll slowly get the word to the guys.
All right, yeah, I'll take the baton there. Is that how you take a handoff, maybe? But John and York, before we get started, would love for y'all to just introduce yourself to all of the LI.FI listeners here. Just give your quick background in the crypto space.
of course, York's more interesting, so I'll let him go first.
I don't believe that. Hey, can you hear me? Awesome.
Yes.
Awesome.
Yep.
Yeah, the icon wasn't moving. Yeah, I've been in the crypto space for a while. Definitely focused on kind of just smart contract layer and programmable money. Worked at Consensus for a little bit on some early identity stuff, and later went to work on the Celo project. Worked on their stablecoin as well as their identity mechanism for kind of mapping or creating like a privacy preserving mapping from phone numbers to on-chain identifiers. And then spent some time at Gauntlet working on basically DeFi insurance and kind of optimizing DeFi protocols for mitigating these like catastrophic failures. And yeah, now I'm on the Hyperlane project trying to bring security to the interchain space. I think have I guess experience to offer that hopefully and perspective to offer that I think is much needed. So yeah, I'll pass it over to John.
Yeah, Eric's very humble. He's he's an integral part of what we do here. We couldn't do it without him. And, I don't think that's an understatement. So myself, I've been in crypto for about 5 years now. It's crazy that things so fast. You asked me just a few years ago if I would expected that things would happen the way that they have. I would have thought yes, but by like 2030, not by 2022. Before crypto was a boring bond trader. I worked at Morgan Stanley for a few years. Around that time, around like 2016, got very, very interested in crypto, but it wasn't really until 2017 where I kind of decided that I'm going to make that the focus of my life and kind of just do everything I can to first get into the industry and second make it grow, and really became fascinated with this thing and just had this single-minded focus on just like making it grow and making what I call it the crypto economy, making. And so initially I felt like the best way for me to contribute was by working with founders. So I became a venture investor, really spent the first 4.5 or so years of my time in crypto as a venture investor. Most recently, I co-led the team at Galaxy. Most people know it as like Novogratz's firm. It was a great place to be, and we had a good run there. And then, the kind of chance occurrence that led to Hyperlane being founded came about, give or take a year ago today. I'd always been very interested with the concept of interoperability because it seemed to me as like the next big shoe to drop, insofar as like the expansion of the crypto economy, right? Like, how do we make this thing go mainstream? How do we create more value? Like, well, these internet computers can't just remain isolated. They can't be, for all intents and purposes, in different galaxies. We have to create the connective tissue between them. And then, with the help of York and our other co-founders, Asa and Nam, and we're just like the great team that we have here, and we're able to put together what we think is a very compelling protocol and platform, right? Because the protocol is just one part of what we're building here. So with that, that's I think it about myself, and love to get into whatever you guys want to talk about today.
Just before we start, I want to say happy birthday then to Hyperlane.
Thank you. Yeah, it's coming up. Like, the official would probably be a few weeks from today, but it's it was kind of like late September, early October where it really came to life.
The first call started a year ago today. Nice.
So thank you for that.
Oh, I didn't know we had a birthday in the house. That's exciting.
That's it's like when it's a kid's birthday and you're like, you're not really sure. It's like, but she's about my daughter. She's 1.5. It's like, well, she's kind of a little bit more, a little bit less, but it's okay.
Yeah. Okay. So just to set the stage for this conversation, let's lay the groundwork here. Arjun and I and us at LI.FI, we recently published a comparison article on arbitrary messaging bridges, AMBs for short. For those of you who don't know what an AMB is, to kind of explain it in simple terms, a normal token bridge is allowing you to move token A from chain A to chain B. An arbitrary messaging bridge is allowing you to pass pretty much any piece of data from chain A to chain B. There are tons of AMBs in the space. Hyperlane is one of the 7 that was included in our most recent deep dive. Today, we are just super excited to maybe just talk about the design of Hyperlane, kind of maybe debate a little bit about the trust assumptions made in the design of Hyperlane, and then just see where y'all would situate Hyperlane in the context of other AMBs. So that's kind of the plan for today. I'm super excited to dive into it. And I think the first question that we should ask here is, John or York, either of you can take it. But what is Hyperlane? Can you give us maybe the TLDR?
Yeah, that's a great question. It's probably the best one, right? So what we view is Hyperlane, in kind of the simplest terms, is it's a platform for interchain communication, right? And in those 3 words, there's a whole lot more. So there's a protocol that enables you to send arbitrary messages between chains. Those messages can sometimes, when we use the term messages, it gets a little bit confusing for people because they immediately think like text messages or some type of messenger. But in our context, right, those messages could contain bytes about value you're moving around, calling a remote function, calling a function on some remote chain. And so that protocol is definitely a big part of it. But then there's also, like I mentioned, right, the platform surrounding it. So York here has work building the SDK to make utilizing that protocol much easier, to allow you to build what we call interchain applications, right? So apps where the contracts are deployed on many chains. The contracts can be identical or nearly identical, and the SDK and the tools around it, make it function as if it's a singular app, even though it does exist on many chains, so that the user only has to be exposed to one of those endpoints. Some deployer tools to just make your life as a developer easier, debuggers. We also recently launched feature that we've been calling interchain accounts, that the TLDR on which is that you activate remote functions without ever having to deploy a contract on those chains. Because if you kind of survey the landscape of AMBs, as you've mentioned before, you'll notice that all of them right now, for anything other than value transfer, require you to deploy contracts on any chain you want to receive messages on. So your interchain accounts implementation is kind of like a category first, certainly outside of the IBC world. We're very excited about that. But yeah, all of this adds up to create what I first described with 3 words as the interchain communication platform.
Yeah, I can hop in and maybe add a few words of my own. I think you gave a great introduction to AMB as kind of a category, but just to motivate kind of the existence of the category, I think the world we find ourselves in today kind of defers, I guess, interchain choices, interchain security, and interchain UX all to kind of the user. And so if you want to interact with an application on a new chain, you have to basically go through a bunch of third-party apps. You have to, use a third-party token bridge and maybe a third-party custody solution on the new chain. And you kind of have to learn all of these new primitives as an end user, which add a ton of friction to the experience. And then even beyond that, kind of like utility of these applications is limited to the chain that they're on. So you don't have, I guess, the same sort of scaling and network effects that you could have if you had all of the users on all these chains kind of natively interoperable. Right now you have these like siloed applications, siloed liquidity pools on each chain. And so there's just a ton of friction basically in actually users and applications adopting these new chain ecosystems, whether they offer kind of new scaling properties or maybe it's just a lower fee environment. Different users have kind of different priorities, and there end up being very different user demographics on all these chains. And so the end game of the way these applications look is really the user doesn't need to understand which chain or which computation environment they're actually being routed through by an application, but rather an application developer can kind of abstract all of that away from the end user experience. And this is really what we're kind of designing Hyperlane for. It's this developer tool for allowing dApp developers to build their applications within kind of this like natively interchain interoperable architecture that allows all these different user demographics to kind of coexist and benefit from each other's network effects. So, you can imagine for some sort of like lending protocol, maybe the lenders who are providing collateral really care about high security, but maybe don't have as much of a preference or priority for just individual fees. They're not making a lot of transactions generally, but the borrowers might be much more partial to the cost of fees, or it might be a much larger margin on what their user experience looks like. And so those two user dApps, even though they're kind of like two sides of the same protocol or application, really would, it makes sense for them to be routed through different, I guess, security and computation environments or different blockchains in general. And so These are the sorts of architectures we want to enable developers to build out on top of Hyperlane. And we're kind of surveying basically all of the existing dApp architectures and kind of trying to identify these areas where a natively interchain architecture actually just is kind of a far superior architecture for the end user experience. So yeah.
Yeah, for the people playing Bridge podcast bingo at home, we just hit silo, friction. I think abstraction was thrown in there, which those are all just words that we're so familiar with. And you did a great job explaining about why interchain protocols are so important to this space. John, were you going to add something there?
Yeah, I was just, I guess basically on this last thing that you just touched on, right? I think it becomes pretty clear once you're in crypto long enough. I think it's pretty obvious that there have to be many chains, whether it's the Ethereum many rollup world, whether it's the Cosmos many app chain world, or if it's even like the Solana or apples of many heterogeneous frameworks. There's just like once demand hits high, which it must if crypto is going to in our lingo like make it as we all know it can. There's just not enough place for that computation to go, right? And so there have to be many chains. Once you create that, there has to be some easy way to communicate between them. Like right now, are all accepting a state that, to give a simple analogy, it's like, it's as if you're on iOS, I'm on Android, and you try and find me on WhatsApp, and you can't. Like it's a generally unacceptable situation that we all accept now because first the technology to alleviate that issue isn't there, and we're all like we're all enthusiasts. We all have some type of vested interest in this. In many cases, a financial one because of how crypto works. That it makes it easy for us to kind of like ignore this major problem. But we're not getting to billions of users using these systems like as a part of their everyday life if they remain this complex. If my Android version of WhatsApp and your iOS version are in different galaxies, like that it's just not going to cut it. So I think this is a pretty obviously we're super biased. This is what we chose to work on. I guess you guys included in a way at LI.FI, but this is pretty existential for the industry, I think.
Yeah, for sure. I think AMBs are definitely quite important for the industry. And as York explained pretty well, every application is going to be natively interchain in the future. So I'd just like to know, like, it's great that regions and you think about this space so deeply. So what I would like to know what type of principles are important for you guys, and like how have they influenced your design choices while building Hyperlane?
All right, I'll actually out of because he does I'm the dumbest person on the team. I don't do the engineering work. So out of pure respect, I will let York and then I'll round out with kind of what we do as a team.
Cool. Yeah. Thanks, John. Yeah, this is a great question, Arjun. I think this is kind of what differentiates a lot of the different AMB protocols and platforms within your framework. It's kind of which of these properties do the, I guess, platform developers and customers care about. So I think in our case, there's probably 2 or 3 things. So first and foremost, as we've all seen, and as your article notes, the amount of, I guess, capital lost to basically bridge hacks that were a result of individual parties being irresponsible with kind of end user and retail user funds. The amount of capital that's been lost in that is just kind of completely unacceptable. And so I think first and foremost, we're kind of making or started from, I guess, first principles and kind of tried to come up with a security model that makes the most sense and is the most sustainable to the application layer value growing beyond what like any individual party or organization should be responsible for managing or custodying. And I think a lot of the kind of just like simple multi-sig solutions tend to be this just like centralized custodian model. And really that's just inappropriate for these types of systems. So we want to not only because those custodians can kind of take someone's funds away or be irresponsible and lose those funds, but they can actually decide to censor certain users' funds or certain users' transfers that they have identified as against some I guess policy or jurisdictions regulation or et cetera. So really we designed our system with basically this idea that security is not just about kind of, I guess, operating a system and having this like social or reputational trust layer, but also having guarantees that operators can't censor individual users, and there isn't a way for a single party to take away all of the different applications that are built on top's value. So I don't know if the comparison framework touched on this much, but we basically have both. We have fraud proofs for both, I guess, the operators or validators of the bridge. We can basically prove if they have censored a specific cross-chain message through the AMB protocol. And we can also prove that if they've signed a message which wasn't committed to on the source blockchain. So these two forms of proofs were the first thing that we shipped because we really felt these were kind of some of the most important security properties for any of these protocols to have. And I think for the most part, none of the other AMB protocols that have been surveyed do have this property. So that definitely is something that I wanted to highlight. But then beyond that, we have, I guess, this kind of like configuration or parameterization layer that we call sovereign consensus, which allows applications to kind of customize the security properties that they care about beyond what the Hyperlane team and the Hyperlane, I guess, platform developers have prioritized. So what that basically means is there doesn't have to be this shared honeypot of all of the different application layer like value or tokens in a single contract that any operator of the bridge can just fork away. But instead, you allow application developers to really tune and customize the security properties that they care about. And so if that includes, a proof of stake protocol that they want number of or a certain amount of application specific token to have kind of committed to or signed off on a specific cross-chain message, our developer tooling and kind of the SDK we've built out both at the smart contract layer and at the application layer really allows, I guess, those dApp developers to not be beholden to kind of just like specific platform properties. And so those are some of the things that I wanted to highlight. I don't know if John had any additional things.
Yeah, it's from I think the principles that you emphasize as a company and as a team really matter towards the software and tools you end up building. And so for us, as Jörg stated, right, we very, very much care about security. We think it's been one of the biggest issues in our category, and certainly being now an issue that kind of holds back the advancement of the industry as a whole. So it's something we very much prioritize, and everything that Jörg mentioned is kind of how you see that principle coming to life and actually being exemplified through the actions and the work the team puts together. But the other one is actually simplicity. Right, so you could build the most secure system of the world, but if it's so complex no one can use it, or even worse, it's so complex that using it exposes your user to making mistakes that actually render it insecure, then what have you done really? And so for us, we kind of have this relentless obsession with keeping things very simple, easy to understand, easy to work with for our developers. Like one thing we think about a lot is like, how long does it take for someone from the first moment they interface with Hyperlane until they can send their first message? We want to make sure that that is a fairly quick sub 15-minute process. Our shortest time right now is just a little over 10 minutes. That time to success metric for a developer is something we really care about, and we think that how simple the system is a reflection, that metric is a reflection of how simple the system is. So those are really like the core principle that lead development here. And from those, there are downstream elements like keeping the thing, making sure that it can be really fast if it needed to be, right? So like as Jörg mentioned with sovereign consensus, we'll let developers can have a lot of customization and configurability for their security module, but you might want to have it where like transfers of really small amounts. Say if I'm transferring $10 through my app, then like just send it the fastest. I don't necessarily need the most robust security model for that. But if I am emptying a contract, sending over say 7 or 8 figures, then I want to be able to maybe have it to go through like more of an optimistic model with some type of time delay for someone to examine the action. And so those are all things we try to bring to life with our system. Hopefully between our answers that kind of covers what you were going for.
Covered it and more. That was a lot of alpha right there. Yeah. So I think the best place to go next is to maybe dive a little bit deeper into how Hyperlane really works, so we can talk about the specifics of your security, specifically with the POS system that pretty much governs your API, and then the sovereign consensus, which is a very fascinating piece of security that y'all have just kind of implemented. So could you maybe walk the listener through maybe a fake transaction to where you kind kind of walk the listener through where a transaction will hit the POS system, and then where the secondary piece of sovereign consensus security will happen throughout a transaction on your API.
Yeah, for sure.
I'm sorry, you got your hand up, so go ahead.
Great question. I think it's really useful to kind of walk through the life cycle. And I think your framework identified that well. So yeah, Hyperlane is not unique in that it uses a proof of stake distributed validator set to basically attest to the validity of interchain messages. However, the way that this stake is, I guess, secured is unique. So there's actually a separate proof of stake set for each source blockchain. So validators are staked on a source blockchain, and they commit to, or basically they attest or sign outbound communication from that source blockchain. And the reason for that is that the reason why we have them staked on the source blockchain rather than some kind of like specific Hyperlane chain or whatever is because we want to be able to prove fraud, like I described earlier, and actually use those fraud proofs to kind of atomically and deterministically slash these validators if they are misbehaving. And so this is something that is unique to our protocol. But basically, as a user, when you send an outbound message from a specific blockchain, there's a set of validators that are staking on that chain with you, where the user is, that are attesting to the content of that message. Because of kind of some implementation details, we use this data structure called an incremental Merkle tree. I don't want to dive too deep into it, but basically because of some implementation details, we have this censorship resistance property. So this set of validators can either decide to commit to your message or not commit to any messages. And basically, if they choose the latter, they will never get paid because they won't have any fee revenue. So basically, validators are always incentivized to commit to your outbound message. If a quorum of the staking validators on the source chain sign an outbound message, on the destination chain, there's basically a function that runs that verifies that quorum of signatures and allows the message to be processed or basically passed through to the destination smart contract. And so you can kind of think of the system as like basically a set of broadcast channels where each broadcast channel has at minimum the security of this kind of distributed proof of stake validators on that source chain. And this provides us with these kind of like censorship guarantees and introduces basically a predictable and kind of deterministic economic cost to bridge operators or validators committing fraud. And so I think this is kind of another property that's unique to our system. In some of these other systems, because the I guess stake is all concentrated on a specific chain, or there is no proof of stake economic security, and basically there's just kind of like a trusted set of operators. In almost all cases, those operators can decide to collude because there's application layer value that they basically want to siphon away for themselves. And there's no recourse for either the user or the application. And so, we kind of identified that as a huge gap in some of the design of these AMB protocols. And we want to, introduce guarantees for both the end user and the application developer that at least there's this kind of economic security that if the operators of the bridge try and collude and try to commit fraud, there is a specific economic cost of them doing so because they'll be slashed on the source chain. And anyone who has observed this fraud can easily kind of provide witness to that misbehavior. So yeah, at minimum, there's like these economic guarantees that applications and users can kind of use to decide is the security of just the base layer sufficient? But like I alluded to earlier, there's also this kind of sovereign consensus layer, which you can think of as basically a kind of like an application specific security layer that sits between the like base layer proof of stake economic security and end user that decides can basically introduce additional security constraints. So in addition to the Hyperlane proof of stake protocol, there could be an application specific proof of stake protocol or an application specific multisig or an optimistic withdrawal period like John mentioned that kind of allows applications to for specific actions or user intents that are sending cross-chain messages to kind of have specific security constraints applied to them that make sense for that use case. So even like you could have for the same application, depending on the message type or message content, let's say like the amount of market value being passed within a message, you can actually kind of dynamic, you can have basically an arbitrary function that you specify in smart contracts on the destination chain, what security constraints you want to require in addition to this base layer economic security. And so really it's like a combination of this economic guarantee that you have from the base layer and any additional application specific security that developers want to introduce. And so what this allows you to do, I guess like if any of you in the audience are familiar with the Cosmos ecosystem, kind of one of the biggest problems with the Cosmos ecosystem is there's like this cold start problem in that when you want to launch an application on Cosmos and you want to launch a new chain, you have to go out and you have to recruit validators because you need some minimum amount of security for your application to have value. And so in the case of our system, because you have this kind of like platform-wide economic security just by nature of deploying on a blockchain where Hyperlane already is, you don't have to go out initially and recruit this like validator set and get LPs to provide capital, but instead you can leverage the existing economic security of the platform, and then once you've reached product market fit and your application has kind of sufficiently scaled out to the point that you do, I guess, desire kind of stronger security guarantees, this sovereign consensus layer really allows you to scale those security configurations as, I guess, the network and the application, or maybe even the DAO sees fit. And so it's kind of this like quite modular system that solves the cold start problem in many ways for some of these interchain applications. So yeah, hopefully that was like a good overview and not too in the weeds, but yeah, just wanted to kind of walk through all the different layers that applications and users can leverage.
Yeah, definitely. I think that was a comprehensive overview. I mean, so your architecture is kind of dependent on the validators, right? Even with the application level security, they can also have their own validator set. So, I mean, I think you don't have anything public right now. Like, there's no public information available at the moment for the POS setup that you have. So, do you have any alpha for us in terms of like how many validators you'll have, or is that already in the work?
Yeah, so I think, John, if you want to hop in, feel free.
Definitely. Sorry, so you're asking like about the size or like validators in the works?
Yeah. How many validators do you plan to have in your POS, or who have you onboarded already? If you can share those details.
So I can't share too many of the details of the ones that are being onboarded right now, but I guess what I think is, hey, if any of you are on here, sorry, I don't think this is I don't think this is against the rules. Our contracts are pretty okay. Pretty much all the major players are going through some type of onboarding right now. You could think of Figment and Coinbase and Black Daemon and all the usual, and Stake and all the usual suspects when it comes to major validator service providers, as well as some of the, maybe they don't occupy that same kind of like, say, absolute top of the pile tier one, but are still like excellent and running great businesses and have had a lot of tenure and mostly in the Cosmos ecosystem. So whether it's folks like DSRV and Chorus One and a few of the others, all of those will be coming online in the next 2 to 3 months. And from there on out, we want to just open up the set to anyone's participation. So at that point, right, like we anticipate a set expanding plus like past the 24 size, but we don't want to have any, say or control over who gets into that set, right? Obviously, as you're bootstrapping, you're kind of doing a lot of the legwork, but eventually it should just be the merits of the network, its own economics to kind of convince people.
Then I will withhold my follow-up question asking about the number of watchtowers and relayers, but let the record show that we did try to get to alpha for everyone listening.
Well, so on those are actually easier because they're kind of simpler to run. So what I can tell you is that right now, obviously, our company runs both, but we've open sourced the binaries, so anyone could. Some of our pilot applications have been interested in running relayers because the nice thing about running your own relay is that it kind of lets you, I don't know if it's come out yet, if you've noticed this yet in the 40 minutes that we've been talking, but we are very much interested in giving developers a lot of flexibility. If there's one thing we'd really like to be known for that's kind of more in the weeds, is that, we're the developers develop, that we kind of want you to think of us as the platform that you can grow with and not something that you would very quickly outgrow at scale. And so we try to build everything kind of like in a more modular way, in a flexible way, that, a year into not like, shit, I got to get something new because we, by now this doesn't meet our needs. And to that end, like allowing people to run their own relayers and giving them additional flexibility in how to process transactions. Like, what rules do you want to enforce? What rules do you not want to enforce? Like, do you maybe want to subsidize the transaction fees of all your users? Do you want to only subsidize those for certain types of transactions? Well, so with a permissionless and open source like relayer role, it becomes much more possible for you to do that. Now, look, don't expect every team to be running their own relayer. It's just like people don't like running infra when they don't have to. That's why, so like that's why infrastructure as a service has become a real category in the past decade. But having the option is something that people appreciate, and all of that, of course, extends to watchtowers.
Yeah, I just wanted to, I guess, hop in quickly and emphasize, I guess, that a lot of these cases are motivated by the failures that we've observed in the ecosystem. And so definitely, I think both like the operational, I guess, bar for some of these, for operating some of these protocols has been set extremely low. And we're definitely trying to raise that bar. So anywhere we can, we're hoping to basically provide monitoring and operational tools for the community and the ecosystem that develops around the platform to participate in running relayers or in running watchtowers to build these fraud proofs. And both of those roles are completely permissionless, which again is like another unique property of our system. And so they can really scale effectively, and applications can have a guarantee if they're operating their own relayer or their own watchtower, that they're not relying on the Hyperlane team or some specific operator who has maybe some exogenous incentives to being them. And so I think very soon, if not already, we're going to have public Grafana dashboards of all of our operating infrastructure, at least within the Hyperlane team. And all of that will be reusable for kind of this relayer and watchtower ecosystem. So yeah, we're really hoping to, again, get as much public visibility into the state of the operational, I guess, systems as possible, because that's clearly been a problem. I think we saw that in the Nomad hack and several others. So yeah, more to come very soon, I think.
Ooh, I'm gonna have to re-listen to this because that was so much information. But yeah, we'll have to have you on in a few months to maybe just talk about like what type of diversity you're seeing in your validator sets and also your operators of the watchtowers and relayers, because all of that is so fascinating and so under discussed in the space. So we'll definitely have to keep that combo going in the future.
And if we got any searchers, here today, one little bit of alpha I'll give is we totally anticipate that if we become a widely used AMB and there's sufficient activity, we think that some of the sharps are going to start running relayers, because one property of our system, it doesn't order transactions. It doesn't force a certain order on the destination chain. And so, that's all I'll say. You can kind of infer what you want from that, but we think once people kind of realize that, there's only be an uptick in the number of relayers out there, and relayers doing different transaction processing modes because of what the application is us not forcing in order to transactions and just kind of letting the destination chain figure it out through its own process.
Hey, Marco, be sure to cut this when we put it on YouTube, so that alpha state.
Yeah,
Right?
this is going to be left internally. This cannot be left out, at least until it's utilized properly from insider knowledge.
Yeah. Okay. So the last little part of this discussion that we hope to hit, and we're already kind of running out of time. We got y'all. There's been so many great details in this discussion already, but is trust assumptions. And so just to give the listener some basis on what a trust assumption is, Arjun and I kind of define it as any type of decision on top of a base layer blockchain. So anything that is built on top that assumes something else will secure a blockchain on top of like the normal validator set is something called trust assumption. Arjun wrote all the trust assumption pieces in the AMB comparison article. And so I would love to give Arjun the floor here to maybe name a trust assumption, talk about why it worries him maybe a little bit, and then give you the chance to debate him on why Hyperlane has it solved. Arjun, do you want to take it from here?
That was the perfect setup, I have to say, by the way. But yeah, I think we have to start with something that's like very much discussed every time we hear the word trust assumptions. So one thing about bridges that's like looked down upon is if they're externally verified. And of course, Hyperlane uses a validator set. So do you think there's like an inherent risk that's added every time an AMB is a validator set? And like, how do you overcome this risk? Or do you think there's no risk at all added by using a validator set?
It's a great question. I can maybe give my brief answer and then let John hop in. But I think, so definitely there is a broad design space and solution space here. When you try and shoehorn, I guess, like native verification of block headers into these AMB protocols, you introduce basically additional cost and latency to the user experience that we generally view as unacceptable, at least with kind of today's technology. And so that's kind of something that is a conscious trade-off we're making. So rather than like preventing fraud from happening entirely, we instead introduce this kind of predictable and easily I guess observable cost to committing fraud. And so for applications, if there's something that exceeds that specific I guess like disincentive for this external validator set, then there might be a need to introduce some additional sovereign consensus basically like property. So maybe it's you want to have an optimistic system on top for specific types of, maybe it's like cross-chain governance that latency matters less for, or like the cost of actually executing the cross-chain governance proposals matters less for. Then you can introduce these additional layers. But I think we think like the base layer needs to prioritize the end user experience for these things to become widely, I guess, integrated within application architectures. And so that means making a trade-off between cost, latency, and security. And we think that our model of having the validator sets staking on the source chain does, I guess, mitigate the potential for, I guess, these sorts of like to be able to just, take rug the system basically, but obviously it's a trade-off.
Mm-hmm. And I think you have, sorry, go on.
I was gonna say, like, the one thing is, in the last part of your question, Arjun, you were mentioning is like, you think there might not be any risk at all. And I'd say, if you hear anyone in any context involving smart contracts, most certainly if it involves any interchain capability, and they say something as no risk, just very, very much stay away from that person. That is a charlatan and a fraud. I'd be very weary of anyone who kind of tries to push that, because everything involves a trade-off. We understand that these systems incur more risk. It mightn't be very little. The actual incremental addition might be very little, but it's there. It is not zero, and so we do everything we can to mitigate that. And again, as you stated, thinking in what we're taking by this action, what is the trade-off we're taking by exposing this to a developer. It's something that's top of our mind, basically every day.
I think that's a very honest answer. And to be fair, we don't expect teams to say that, oh no, our bridge is the best and it's the most secure solution out there. But what's important is for every team to kind of accept the trade-offs they've made and not portray that they have not, right? And you guys do that that's commendable.
Of course.
Oh, is that your only trust assumption, Arjun?
We've covered everything in the 1 hour that we've been talking. So, yeah.
Well, so I think it's again, kind of if you think back to where we started when you asked us, what are some of the principles that we're building this thing with, right? So what did we say? We said that those are security and simplicity of the system. And so our goal is, through the use of sovereign consensus, to get to a point that any developer that wants to have as close to zero trust assumptions with our system can achieve that. Right? One implementation of sovereign consensus is one where the developer could basically force a signer being required into any message that would get processed affecting them. And in that sense, you really don't have an outlying trust assumption to some external party. And you would control that signer. And if it's not in, it doesn't matter if 99 validators said that the sky is red. If your validator says, nope, the sky is blue, that message is not getting processed. And so the system does enable at least one path where you'll never depend on, you'll never have an outstanding trust assumption with us. Or, and when I say us, I mean to describe the external network. But certainly, to be realistic, that's probably not going to be something that is the predominant mode of operation for most Hyperlane developers, certainly not in the early days.
Beautiful. Well, I think we only have about 5 minutes left, so I have 2 questions that I'm gonna drop. We'll do a lightning round here. But what I always like to ask AMBs is, first of all, do you think this is going to be a one bridge to rule them all type environment going forward, or do you see the space continuing to grow? Right now this AMB article we did has 7 bridges. We probably could have done 10 to 15 if Arjun and I didn't sleep. I know I'm sleeping to no sleep, John. So
We will add them.
But I just wanted to know what Hyperlane thinks about other bridges, competition, and where y'all fit into that.
For sure. So I'd say, in lightning round fashion, to the first question, definitely not going to be a one to rule them all insofar as the actual message passing protocols, because they all have different trade-offs. So that's where I'd expect something layers like LI.FI to kind of help with decision making, which pipes should get used for this message, because different messages are going to have like different things that they care about. Like, hey, if I need to get there in, you know, in 1 second, then like find the path that gets me there in 1 second. If I need to get there in the most secure way, like I can't have anything fuck with this, then maybe I take, you know, the longer route, and that might entail different protocols. Certainly we're biased, and we'll tell you that with Hyperlane, like in the end game, it'll kind of set of all the paths, but that's for a different conversation. So we definitely expect there will be many protocols on, you know, when it comes to like the overall platform, right? So as I mentioned before, there's the actual like protocol, and then there's everything around it. The everything around it actually might be an area where there is much more like dominance and market share owned by a single player, because like now you're talking about like, how does it feel to use this system? How does this system find itself in front of many more users? And like realistically, I think there's a world in which other people's like interfaces end up routing to protocols that are different than the one they started with, right? So like, say, you know, to not upset anybody, let's say like Hyperlane ends up being super successful with like the interfaces that we build, but a year from now, someone actually ends up building like an incredible set of pipes that for our users is just the best set of pipes, and for whatever reason, like maybe they have special licenses around it, or just involve something so complex we can't figure it out, we might just end up routing you to those pipes. And so I think like more competition at the pipes, and less like winner take all dynamics, and more of those, you know, winner take most, maybe even winner take all dynamics, you know, above the pipes at the interfaces.
Beautiful. Okay, last question. Okay, it's another two-parter. I have like 30 questions left on our document.
Well, we'll come up hey, just to make clear, you know, we'll do this, you know, we'll do this once a week if you want. We had some fun.
Yes.
Okay.
Yes.
But last two. First, what is the coolest use case that you envision Hyperlane entering in the next 6 to 12 months? And then number two, what should we be looking for from the Hyperlane team next? And then
that's so easy. I bet York and I have the same too. It would be basically like smart order routing for block space, or like for computation, right? York, what would have been your answer?
Yeah, I think so. I mean, in general, just like having applications instead of like specifying, you know, which chain they're going to expose certain functions to. Having like a routing policy like does that dynamically based on, you know, gas prices or basically anything along those lines. I think makes a ton of sense.
And to your other question about like what's next, so good, real quick, so you can anticipate more like quality of life upgrades around like usage of the system. Those will be added kind of at a regular. You can expect something that changes how Hyperlane adds new chains and who can add them. And you know, I don't want to say too much this because we got to keep, you know, some alpha for the future. But we think it's something that you could uniquely do with Hyperlane that with other AMBs that really changes the game. And if we're paying attention to what we were saying before, right, we really care about people viewing this as a system that grows with them and doesn't, you know, will never leave them behind. So think in that way. And then there's something we think very interesting that we're going to be doing with basically like turning our developers and their into a real part of the platform. And once we're ready to give you a bit more on that, we'll be more specific. But those are the three biggest things.
That's awesome. Like, the whole conversation is full of alpha, as Mark said. We're gonna have to re-listen a couple of times to digest it. I'm sure listeners as well. Before we wrap it up, I have one more question. I'm interested. Can you share any of the projects or protocols building on top of you, or it's still
Yeah.
hush hush? Awesome.
No. There's I'd say probably like the ones that would have the least no objections as far as we know to us mentioning it are Yama Finance. Yama is the kind of the TLDR on what they're doing. It's really interesting. It's sort of like an interchain maker that creates an interchain stablecoin. Then we have somewhat related projects in their function, but pretty different in their implementation in the refi world of Flow Carbon and Toucan. Both are like creating markets for the issuance and redemption of carbon credits. Then there's others, but like these are the ones where we talk to them regularly. We know like no complaints from them. And we actually had some amazing submissions from ETH Online that came in yesterday that we'll be sharing on our Twitter account.
Nice. Looking forward to checking that out. So for all of your listeners as well, this interview podcast, AMA, however you want to call it, it's going to be published on YouTube, so everyone can re-listen. Maybe a part of it will be cut out. No promises there. And before that's published, you can go and read the AMB Bible and get all the deets on Hyperlane from it, written by Arjun and Mark. I want to say thank you, Yorkie. The conversation was amazing. A lot of good information. I really hope we can do this again sometime soon.
Same here. We'll just let us know. We'd be happy to come on.
Awesome.
Yep.
Awesome.
Thanks for having us.
Thank you, everyone.
Thanks everyone for listening. And have the great rest